Hey, Professor Davis here. Now we are in part 3, using scientific and E notation. Now, before we can, go ahead and start to compute with it, let's talk about why we even want to talk about this kind of odd sort of notation for numbers. Well, the reason is a lot of times in statistics, we have to work with extremely small numbers. In particular, extremely small probabilities. And a lot of times, a calculator or a computer will write those using either scientific notation or this E, sometimes called exponential or engineering notation. So let's go ahead and explain how it works, what the notation is, and how we can convert it using our calculator and by hand. So exponential notation, or E notation, is a way that we can use to express very small numbers. Now notice the form here. A and then E for exponent, and then minus B is equivalent to the scientific notation form of A times 10 to the negative B. All right? So those two expressions say the same thing. A minus B, where A is a number and B is a whole number, and then A times 10 to the minus B, again, B being a whole number, A being some number, all right? So those are the two equivalents. So to write E to the minus B in decimal form, we start at A and move the decimal point B places to the left. All right, so we start at the right of A, so to speak. Move the decimal point B places to the left. That makes the number smaller. All right. To write a decimal number in E notation, all right, what we want to do is to write A and then count the number of decimal places to get to the right of A. That's the value of negative B that we'll use. All right. So let's see how this works now, and we can see how our calculator can help us with some of this, because this is something that students get confused about. They're not sure how to recognize very small probabilities, and that's what this E notation and exponential notation does. All right, so let's write this fraction, 5 over 20,000, in scientific notation and then in decimal form. All right. So first, let me grab my calculator here and my Casio, and I'll go ahead and put in 5 divided by 20,000. All right, go ahead and hit the equal sign here. And notice here, it reduced the fraction by 5, right? So 5 20,000ths is really 1/4,000th. Now, to write that in scientific notation, all we have to do is to hit our old friend here, the SD key. So what do we get there? 2.5 times 10 to the negative 4th power. All right, so there is the scientific notation form, and this is the form you see on the Casio calculator for very small numbers. All right, scientific notation. Now let's try with our graphing calculator now. So I'll go ahead and put in our number here, 5 over 20,000. Go ahead and hit enter, and notice automatically we get that exponential, that E notation, 2.5 E minus 4. So these two expressions say exactly the same thing. 2.5 times 10 to the negative 4th is the same as 2.5 E minus 4. All right? And then, in decimal form, think of what we want to do. We want to take the decimal here, move it 4 places to the left. 1, 2, 3, 4 in our mind. So when we do that, notice what we get. Move the decimal 1, 2, 3, 4 places. There we are. All right. So we start with in decimal form. We have a decimal point, and then to the right of that, 3 zeros, and then the 2 and the 5. All right. So that is 5 20,000ths written in decimal form, also written in scientific notation, and then finally written in this E notation, the exponential notation. All right. So let's just review one more time. Here's the E notation. It says negative 4, and so we start at 2.5, where the decimal is over here at A, so to speak, and we move 1, 2, 3, 4 places to the left. All right, let's try one more example here. Make sure we got the idea. Write 4e negative 6 in scientific notation and then in decimal form. All right, Well, that's pretty easy. I don't think we need a calculator for this. In scientific notation, this would just be what? 4 times 10 to the negative 6 power. So that's a small number, isn't it? Now, in decimal form, think what we want to do. We want to start at the 4 here, to the right of the 4, so to speak. Move the decimal point 6 places to the left in our mind here. All right, so when we do that, think of what it looks like. What? 0.00004. All right, so what did we do there? We took the decimal point that was just after the 4, moved it 1, 2, 3, 4, 5, 6 places to the left. All right, so these two numbers here are equivalent. All right, so that's something super important for us to recognize when we start to look at probability, because a lot of the probabilities we look at are extremely small like this. So that's why it's important for us to be able to convert numbers from decimal form and into scientific notation and E notation or exponential notation. So there it is, part 3 of Essentials of Statistics.